Welcome to the final video on recursion. In this video we're going to be looking at functional recursion in situations where you're trying to find a particular value. As an example of this, I'm going to use changing number bases. Now we use base 10, everybody knows that, but that wasn't always the case, and in fact isn't even the case all the time now. You've probably heard of binary and hexadecimal, which computers use, but you also have had other number bases that have been used over time. For example, the ancient Babylonian priests used 12, but the peasants who worked the fields, they used 5. And when they wanted to talk to each other, they needed a number base that worked for both of them. So they used 60, which is why we have 60 seconds in a minute, 60 minutes in an hour, 12 months of the year, and so on. Now this program asks which number you would like to change. It then asks for the number base that you would like to change it into. And finally, it prints out the number in base whatever is, and then the new version of that number. It calls a function called Changebase. Changebase takes 3 values. It takes my number, but notice that I've forced it to be an integer because you can't change bases of decimals, or not that easily. It asks for the base, again as an integer, and it passes an empty string. The purpose of the empty string will become apparent in a little bit. But first of all, let's see what happens when we run this particular program. It asks me which number I'd like to change. So I'm going to type in 503, say. And it says which number base would I like it into. So if I wanted it in binary, I could say 2. And it says 503 in base 2 is, and there's that number base. I could try it in hexadecimal. So I could say 503 in base 16, hexadecimal, is 1F7. That's how the number base program works. But let's have a look at the magic bit, the bit that does all the calculations. Here is the function Changebase, and as you can see it requires the same 3 inputs, a number, a base and the result. Both the number and the result will change as we go through the recursion. It calculates the remainder and does its own magic. That's all part of the maths, and we're not doing the maths here. The only interesting thing here is that if the digit it returns is greater than 9, it turns it into a capital letter. But that's all that's going on there. The main part of this function is the bit down below here. It adds the digit to the front of the result, so we have a new version of the result. And if the remainder is 0, and this is the base case, if the remainder is 0, it returns whatever the result is. If it isn't 0, if the remainder still hasn't got to that 0 state, then it runs Changebase again with 3 pieces of information. In this case, it sends in the remainder, the base that we're looking for, and that new version of the result. And it keeps going round until it gets a remainder of 0. As before, in Python, you need a return in front of the functional call. So we need return Changebase. It keeps going round that until it meets the base case, the remainder equals 0, and then it can return the result to us. This is a function that calls itself. If it calls itself, it's recursion. And in this case, the function returns the number in the new base. Thank you.